everyone. Myself Solanki. I am from Isfatment, and now today we arrange webinar on automation, industrial automation system. In this topic, we cover the whole industrial automation system using the different tools like HMI, SCADA, and AC Drive. For that, I welcome to our speaker today, host Mr. Nandu Anand Nityanandan from NCVT Ahmedabad, and he is most senior faculty and 5 years experience for automation training. So please welcome Mr. Nandu Anand sir, and please start uh, your session. Sir, your voice is not audible. Nandu Anand sir.
Hello, hello, hello.
Yes, sir, you're
Nandu
audible.
Anand sir. Yes, sir. Yes.
Okay,
Okay,
I can start
audible.
again if you want. Is it my voice clear?
Yes, sir.
Hello,
Start your session.
hello. My name is
Yes, sir.
Nandu Anand. I'm an
Yes,
engineer
sir.
representing NCVT Private Limited. I'm here in behalf of NCVT Private Limited as well as your Parallel University to present you a presentation on industrial automation, its architecture, and its evolution, and what are the components related with that technology. NCVT Private, first of all, I will like to explain you about my company. NCVT Private Limited is an engineering company which is running in this field since last 16 years. We are closely related with industrial services and solution providers, as well as we provide technical skill related to the same. And we provide an HR consultant services. Hope so that you enjoy this session. First of all, I will give you a brief introduction about what is industrial automation. To start that, we will start with general basic sense what is automation. So automation is a closed loop system which is closely related to your field input devices, control system, and your control hardware. When you start your session, you have to know what kind of input devices you are dealing with and what is your control parameter. And according to that, you will control any systems. To start that, you have to understand what kind of input sensors you are required. So you have to know what are the input devices, what are your control hardware, and what are your final control element. So according to that, your loop will function. Okay, I hope so you understand that. Let's start with the PPT presentation. Is this PPT visual right now? As you can see, our presentation is about industrial automation. So we will start with the foundation as an architecture of an industrial automation, or you can say it's an architecture for any kind of machines or process which is related to your automations and its various software and hardware related to that. As you can see on the screen, this is the basic architecture of any automation. If it is industrial automation or any kind of automation, you can closely relate with this. As you can see in this architectural chart, it start with your process instruments or sensors, which you known as input devices. This input devices its role is to sense the parameters which you can known as temperature, pressure, flow, level. This kind of parameter is sensed by sensors, and that signal is given to your control hardware, which is known as PLC in our case. As PLCs and specially designed industrial hardware, it closely relate with your field input devices and field output devices, and you can say that it's a programmable interface which can be programmed or reprogrammed as per your application or as per your user requirement. According to that, that signal is provided to your control hardware. As you can see, your final control element is 14th number: control valve, compressor, motors, any devices which are at the end which are going to be controlled, that are known as final control element. When you provide signal from your input signal, means your sensors, to your control hardware, according to your program or according to your set value, it will provide some signal, and which has to be given to your control hardware. But you can't directly provide this signal to your controller, to your final control element, because PLC belongs from an electronic power electronic sites, whereas your motors, compressor, control valve belong from an electrical family which requires heavy electrical supply, but your controller can't provide that much supply directly. So we will have to introduce switch gear devices, which is 11 number, to provide that switching and triggering with respect to your controller to your final control element as per your applications. According to that, you have to install that switchgear devices into panel. You can know that a panel is an important part in any kind of industries. It is related to process or it is related to machines. If it is there, then that means your switchgear devices or your control hardware are most probably installed in that panel itself. To understand panel, you have to understand how it is designed, what are the requirement for making a panel, how can you erect a panel as per your requirement, and what are the steps followed, known as commissioning, maintaining, and loop testing. After creating panel, you can sure that your signal will be provided to your control output, but you can't say if it is functioning or not, because there is no such a thing that tells you that it has been completed or not. Because if you are installed this panel for a machine, so the machine will function as you provide a raw material, and at the outcome it will provide you with the product. So the processing has completed, you will get only the outcome, but you won't be able to understand if the process is in intermediate state, or if there is any kind of trouble, or where what stage it is currently. So to solve that, you have to install an monitoring system. So when you provide a machine with a monitoring system, so you have to add HMI system as a monitoring purpose for that individual machine or that individual panel. HMI, you can say it's an hardware display which provides an interface which functions with respect to your control hardware. That means you have to make a communication or network between your control hardware and your HMI systems. This kind of systems are generally used for machine level monitoring system, but for suppose you have more than 50 to 60 machines, so it is hard for each and every person to collect data from this much number of machines. To resolve that kind of system, there is a SCADA monitoring system. I think you have might heard of a term control room monitoring system or control room control system. So the SCADA is an software based monitoring system which is used for such purposes. By SCADA, you can collect the data from the numbers of machines to a centralized location. From that centralized location, you can provide the monitoring system required from that control room. In that, there won't be any kind of delay or any kind of signal you have to monitor. You can directly monitor from there itself. So in simple sense, I can say that this architecture represents the industrial automation in general. Let's start next. This PPT consists of introduction to industrial automation, its evolution of technology, and various stages which were in evolution of technologies. Okay, next. So here it explains when what is industrial automation: controlling, managing, supervising of industrial process tasks, machine by electronic power, power electronic instruments, devices, computerized system, network system. Industrial 4.0, which is total automation related the same. Now, today automation is a significant process carried right from pinpoint organization to an aviation technology. So, to generate a small to small product to a aviation technology, you required specific knowledge of automations and related skills. In automation, if you want to generate a pencil, you have to know what accuracy of the thickness you need, as well as if you are generating a aviation panel, you have to know the weight and the thickness and the aerodynamics of the same structure so that it won't crumble in the intense pressure in the aviation field. As automation is constantly evolving, so there are many stages which occur to the automation. But as you can say, our competitive market, or you can say cutthroat competitive market, challenges has been involved in that. According to that, there got a boost in the evolution of this technology in such a way that in every few months something new has been creating so that the competitive market can be evolved accordingly. Now there is the this question will comes to you or mind every time when you heard about automation. Why automation is needed? What the implementation of automation provides? Generally, in simple sense, a person can say it functions automatically, but that's not an engineering term. In engineering sense, you can say a process or machine which is self-sustained or self-correcting is an automatic systems rather than an illiterate term that you can say it's an automatic process. That's why it's known as automation. You can say if you are not an engineer, then that description would be fine. But as an engineer, you should know how automation functions and what are the requirements and advantages of that automations. So, which that what I covered previously. Let's discuss about the implementation of automation. By implementing automation, you can increase the productivity and quality of your product. You can increase the number of production. You can increase your quality of the production without having any kind of delay, as it won't get frustrated that it I won't function for further or anything like that. Machine won't complain and machine will function as accurately as you provide its command to. By using automation, you can reduce cost, longer plant life, and machine life. This statement is kind of contradict. I can explain you how. Why automation? It is quite costly, but by providing automation, you can provide a long-term economical plan. According to that, you won't have to spend much in future if you provide an automated system currently. That's kind of a like one time investment. And automation technology, the component which are used in that technology has longer life and machine life. So it, if you provide regular based maintenance and servicing for that machines or that components, it will last for a long time. Another point is less manpower and functional error. Point is that less manpower, it is not said that if automation is there is no requirement for manpower. Manpower is required, but specific skilled manpower is required. So if person knows its technology and component, it would be required for that person to install or to design such a system, and to sustain that system he has to provide such kind of maintenance and regular services to that systems. So manpower is reduced, but skilled manpower is required. And if there is skilled manpower, so according to that, the functional error will be drastically decreased, so that you can say that your system can functions properly without any kind of hurdle. Safer working environment and reduce power expenditure. Safer working environment and reduce power expenditure is a point which representing its predecessor in technology. When there was manual based system, or you can say pneumatic based system, it was quite huddled to work in industry, because as it is pneumatic system, you have requirement for compressed air to operate any kind of systems. So we will discuss on that on next topic. Now, reduce commissioning and troubleshooting period. This point represent the same case as if you are using a air based system or electrical based system. So commissioning, that means installation, testing and commissioning period will take a long time for that kind of system to be built, and according to that, the troubleshooting period for that system would be high. But in case of automation, you can reduce your commissioning period with a lesser time, as you can provide a control panel with pre-installed component. Thus you have to only wire the specific input and output, and according to that, your system will be ready for functioning. And in the same way, when you are using panel, the troubleshooting period will be drastically reduced, so that you can easily uh, trace out any kind of trouble, and you can provide that kind of troubleshooting to that system. Now, by using automation, it is easily implementation for complex logic, because you can program such logic in such a way that you don't have to have any kind of lag in wiring or any such precautions. So you can say that by automation, the complexity can be reduced, and it is easily, you can say, centralized and redundant control plus monitoring. Now, centralized means you can control such a system from a remote location, such as control room, easily, and collect data of your entire plant, and can be collected to that centralized station. That why it is known as centralized station. And redundant control means if there is any kind of failure in such a system, it has its real time redundancy, means backup plan. So according to that, it will functions and implement your systems. Now, then monitoring. As we discussed in the architecture, by automation, you can provide machine level monitoring as well as centralized control room monitoring. Now, evolution of technology. Let's start with that. The automation technology, or in case just we can say technology started in 19th century. It started with manual control, which you can say that you have to do your works by directly involving in that. And according to that, you have to switch to pneumatic systems. The next stage was pneumatic, in which you have to function using air supply and related structures. And next was hydraulic, in that we used oil or fluid pressure to deliver same functions. Then came the electrical system, which we known as hardwire technology, in which you have to wired each and every component using electrical systems. and which was, you can say, a great achievement in related to air compressor based systems, which was quite of safe, and in, you can say, it has its own advantage from its predecessors. And then came the electronic era, which you can say it was the boost era, which is currently running right now, in which you developed circuit boards, and according to that there was an unprecedented growth in the function of, or in the evolution of technology. Today you can find electronics in any kind of industries like embedded, aerospace, aeronautical, and industrial engineering. Software, electronic controllers, and networking play a significant roles. That may you know that previously, if you want to control or design any kind of controller, you have the knowledge for that particular hardware as well as its software to develop that kind of programming and integration. And according to that, your function will be functioning. Let's discuss the evolution of technology. History of automation. It started with manual control at the time of era when you have to implement each and every task by doing manual functions like pick and place, filling of the structures, whatever you needed, you have to do it manually. Then came the era of pneumatic controls. Pneumatic control was an era in which mainly the systems or machines were functioning in on or off condition or pull or place conditions. In this condition, it was mainly functioning with respect to compressed air. That why it's known as pneumatic systems. Then came hardwire logic, or you can say it's an electrical system where in which each and every component were hardwired to your electrical system, and according to that your control were conducted. Then came your electronics, which were functioning as per your logic gates. You can say logic gates were the first prior functions which were created in the form of automations, because automation generally functions in close relation to logics, and electronics started that era. Then came PLC controls. PLC, as you may know, it's a programmable logic controller. You can say it's an evolved version of your electronic era, which is specially designed for industrial application, in which you can provide your industrial inputs and output devices and directly relate to that and control your system. Then came SCADA and PLC control. In PLC control, the controlling was possible, but it was like a blind control. You won't able to understand if your function has been completed or there is kind of delay or any kind of structure such that. So to resolve that, the engineers which were working on that PLC developed a monitoring system which is known as SCADA. You know its full name. It can be supervisory control and data acquisition, which is used for the monitoring of the function which is functioned by PLC in real time. And then came the DCS system. DCS system in simple sense, you can say that a system which has distributed the functions of various process in divisions to multiple PLC and SCADA system. Now let's discuss about manual control. As I explained prior, manual control, or you can say it's an mechanical control, is closely done by persons or human body directly. There is no kind of machinery or mechanism used. There was only mechanical controls as well as a human load to operate such a condition. But it has a huge disadvantages, as human has limitation. He can't be able to perform full day 24/7. So the human limitation was the core problem or this technological body, as error and the quality of the product was hard to maintain, as well as the machine and execution process was, you can say, not that up to mark to provide your product quality. The expenditure of energy and usage of raw material, or in case of damaging of that raw material, was very uh, crucial, and which was directly indirectly related to the decision made by that human body performing that specific structure. These are the examples which you can say for manual control, as furnace, chemical boiler, grinding machine, or rolling mills were directly functioned by human body. silos and cutting machines were operated, and factories and industrials were even also done in that time by human controls. Now you can imagine this kind of industries like oil refinery or 24-hour production or pharmaceuticals, even beverages and food industries, printing press or HVAC control, furnace or boiler control, or even access control or PCB design. It won't be possible in current generation to done without automation, because it is kind, you can say, impossible right now to such precautions and such perfection in today's world. Now, pneumatic and hydraulic system. Pneumatic hydraulic systems came at the same time. That's why this topic is combining it together. Pneumatic and hydraulic systems, where you can say a system which directly functions in discrete operation like opening, closing, pull or release, or mechanical alignment, in which generally the specific functions were operated by pneumatic components like pneumatic valve, pneumatic mechanical arms, air compressor based equipments, and etc. It increased the production in compared to manual control. It has drastic changes related to that, but it too contain its own disadvantages. So let's go through that disadvantages right now. The disadvantages was, the first, it had bulky component and the construction required for that was quite hard. So according to, you can say that the commissioning time and troubleshooting time related to the pneumatic or hydraulic system was quite high. That means if there is any kind of problem, it may take longer in compared to solve that system, so you can't able to function properly as estimated. Plenty of energy consumption were needed, as your components which you use in your systems were constantly required of air compressed or hydraulic pressure to function that process. Virtually impossible to change logic, because as it takes a long duration to establish such a system, it won't be easy to change logic as per your requirement. Longer commissioning and troubleshooting period we discussed earlier. Wear and tear of equipment because of the moving part. As this functions as per your pneumatic or hydraulic systems, the relation of pressure was quietly there. According to that, the quiet vibration would provide, and according to that, your equipment and your moving parts would get tear and wear as per the use. And as you are using compressor, it would be quite noisy and it would be a less safer environment for any kind of person to function. So these were the basic disadvantages related to pneumatic systems. Compressor, generators, heaters, steam mixers were the quite big examples related to these things. Today you can also find pneumatic based systems in industrial platform to lifting heavy weights and something like that using pneumatic pressures. Now let's discuss electrical and hardwire logic. As we know the disadvantages related to pneumatic system, to overcome such a system, electrical fundamentals were discovered, and according to that, the pneumatic devices were replaced with electrical systems and electrical components, as relays, contactor, logical relay, hard timer, counter, starters, and circuit breakers were the quite usable components and required control components for such a systems. Because of this kind of system, a static function was established. According to that, the wear and tear of such systems which were used prior in compressor based system or pneumatic systems were reduced, and your plant and machine life scale was increased. As static component eliminated noisy working environment, means by adding electrical system, we can say we have eliminated the compressor based system, and according to that, the plant expenditure got quite reduced. The construction and the size of machinery was also reduced. And by using electrical system, we have eliminated compressor, mechanical piping, mechanical logic arm, and any component where which were closely related to pneumatic technology were replaced with their alternation of electrical parts or electrical components. Now, disadvantages also consist of this electrical system, which was that when you have to install any kind of component in your plant or machine, the wiring of such a component was much complex, as you have to run each and every component with the supply of power wiring as well as control wiring, which was quite complex in that time. And when you provide a panel structure to wire such number of equipment, the panel itself become too bulky and hard to compromise your functions, and it was difficult to troubleshoot such a panel because it is too heavy and too complex, so you won't be able to find a single problem directly by just observing your panel. As according to that, the commissioning period and schedule of such a structure also rise. Switchgear devices and electrification cost were crucial, as each and every devices required its own contactor relay to operate or to install such a structure. And the high demand of skilled employees for dedicated technicians were rise, as a person who is working in such a panel should have understanding of such a panel wiring, installation and components, so that he can deliver the required function easily and properly. These are the examples which are used in electrical systems, you can see in the screen. As electrical logical wiring implementation were consuming and difficult to change immediately. The statement state that when there was electrical system, it was hard to change any kind of wiring or any kind of implementation directly by the point of thinking. It was quite complex to trace each and every systems and each and every wiring. To resolve that kind of technology, again the engineers combined together to develop such a system in which the same function can be done in a small scale by using some kind of implemented circuit or predefined circuitry to function the same level of operation without any bulkiness or complexity. So the era or decade of 1950s and 60s, the first electronic component, the transistor, was formed. And from the formation of transistor, the evolution of your electronic era was started. With the arrival of electronic circuits, logic gates, timer, counter, potentiometer, etc., made reduction of your panel wiring, troubleshooting, panel size, and electrification cost. This point explains everything. As electronic circuits were small, it uses less energy and run in minimal electrical signal. It was more reliable, static, fast response, and machine efficiency and response became much faster. As you may know that electronic functions much faster in comparison to your electrical system, and it is easy to implement electronic circuit as it is pre-designed, so there is minimal wiring externally required to operate such a circuit, so it was easy to install, replace, or in our case it is fast responding to provide your control hardware. According to that, you can achieve your requirement in your quality and quantity easily and in fast response. Advantages of electronic era in which it requires lesser energy, so you can save energy as well as cost, because the manufacturing of such a component is quite cheaper in comparison its predecessor like pneumatic and hydraulic, or as well as in electrical system. As it's an electronic system, it has high efficiency and it is easy replacement. Execution time and generation function time were reduced. Decision making, you can say the decision making time in this era was quite reduced by electronic components. Troubleshooting and maintenance of small panel is a big advantage over that you can trace any trouble easily, as well as you can maintain small panel easily, which is a big relief in compared to your electrical system or electrical panel. Fast response time and reliable control, as you can program electronic functions, so it won't function beyond your electronic domain. So you don't have to worry about that changing or any kind of parameter. It will function as defined and provide your control hardware as assigned by the developing person. And there are many more advantages, as you know. Disadvantages: change in control logic with dedicated circuit was quite of impossible. uh, that means if there is any kind of change required for minor changes, then also you have to replace the entire circuit, as the circuit was designed for a specific application. So change in that kind of domain is quite hard. It was difficult to produce centralized control panel, as it's an electronic circuit, so it won't be able to provide the signal for long distance. So centralized control was quite difficult. Different to isolate electrical and electronic signal. As you may know, electrical signal provide it kind of EMF around its surrounding, and electronic signal is kind of an weak signal, so it may get influence using electrical system. So it was difficult to control electrical and electronic signal in the same place. Smart operator interface is requirement, because it is a kind of a skilled job to develop or to function in electronic domain. So it won't be easy for any person to function in such a environment. So smart interface and smart operators were requirement, and it was difficult to control electrical, heavy electrical and light electronic signal at the same time in a same place with the same panel. So separate circuitry for heavy as well as separate circuitry for light were implemented, which was quite difficult and time consuming as well as costly. These are the examples of electronic era in which you may have uh, signal comparisons, data managing, and so on. Now, our next topic is PLC, Programmable Logic Controller. Programmable Logic Controller was based on microprocessor, which was developed in 1970s. And according to that, it was formed in such a way that you can program as per your requirement and application. So the product PLC was developed accordingly, in which achievement of desired control or automation through physical wiring of control devices in PLC. It is achieved through a program or software. In its predecessor, in the previous control technology, when you have to provide each and every wiring and logic using that such hard wiring control, it was solved by PLC by doing such a thing by just providing the required program or logic using softwares or its control hardwares, and according to that the required functions were achieved. Programmable controller have in this recent year experience an unprecedented growth as an universal element in industrial automation. It can be effectively used in application ranging from simple controls like replacing small number of relay to a complex automation problems. You can say that any kind of switching which was possible prior in hardwire logic can be implemented easily without such kind of complex wiring with the help of PLC by programming the PLC as per the customer's requirement. Now, what is PLC? In simple sense, programmable interface between a field input devices and field output devices. You can say it's an PLC, but it's kind of complex than that. PLC is an specially designed industrial hardware which works as a programmable interface. PLC is specially designed for industrial application. As you may know, industry is not covered properly. It may have consumed dust, humidity, which may have its own disadvantage to your process or plant. So PLC is a controller which is specially designed in a way to withstand that kind of problems, and it provides a programmable interface between your field input devices and field output devices. Means it makes an intermediate state between your input devices and output devices. It takes signal from various field input devices, say your process instruments or sensors, and compare those signal with your defined program or your set value and generate your control output signal. According to that, your output signal or output devices are functioned. In simple sense, it means that it collects data or information from your field, which is collected by your process instruments, also known as sensors, and provide that signal to your control hardware, on which you provide your predefined conditions, which is called program. And it compares that signal with your measured value, which is measured from sensors, and provide your control output, which is again given to your control devices. This is the way your PLC functions. As explained earlier, the PLC collects data from your field inputs devices. That signal is given to your processor. Now, as your PLC, it consists of a microcontroller. It can't directly understand any kind of electrical signal. So, in this scenario, you have to control this inputs signal and convert that into an input image file, which is in binary, so that your controller can easily read and understand such a problem. And that signal is compared with your control program, and according to that it would generate your output image, and that image is again given to your output devices, so your input signal can implement the function and provide to your output devices. Now this cycle is known as scan cycle. In this cycle, it collects information from your field, compared to its program, and provide the control output, which is again given to your control output devices. Now this cycle consists of two kind of delay, which is in the conclusion is known as scan time cycle. This delay is caused by input output interference or decision making delay. So these are the two interrupt or two delay which is closely related to your scan time cycle. Now basic component of PLC. If you see PLC, it consists of its own chassis on which your each and every module is mounted. Now, PLC has its own power supply module in which you provide a common supply, and that supply module will distribute that required amount of supply to each and every module in that PLC. PLC consists of its own CPU module as well as communication module. CPU module consists of its logical component which provide the algorithm according to which your process will implement. And communication module plays the part of communicating or developing of network between PLC, HMI, SCADA, VFD or any various component used in your application. Other than that, PLC consists of an input module and output module. Input module plays the role of an intermediate between your field input devices and your CPU. It collects data from various input devices and provide that data to your CPU. In the same way, output module collects the controlled data or controlled information from CPU and delivered that data to your field control devices in your field. I hope so you understand the basic component or basic architecture for PLC. Now, advantages of PLC. Advantages, the main advantage of PLC is that it reduces the hardware logic and electrification cost in any kind of industry in comparison to its prior technologies. As it's an electronic based system, the energy requirement to operate such a controller is comparatively low, and as it's a programmable controller, it has a fast response time in comparative your electrical systems. Sharp, easy logic change and re-logicking can be implemented. Means you can make any kind of complexity easier in logical way or in programmable way to your process in this process by using PLC. Longest life and reliability with tremendous flexibility. You can change your logic and implement your function with reliability that it won't function other than given task. It is much economical in longer run because it only cost one time, and as per that costing, it would be more reliable and provide a quality and quantity controlled environment so that you can uh, generate a steady income so that it can be said it's an economical in longer run. Shortest troubleshooting period and the timing for checking and changing of logic, as PLC is an programmable interface. If you want to check or troubleshoot any kind of logic, you can directly do that from using its own software. As well as while using PLC, the wiring is quite reduced, so the troubleshooting of such wiring is also easy and easily implemented and fast functioning in any case of troubleshooting. As the program is in software, you can easily save that in computer, as well as you can provide and copy to your PLC, as well as you can achieve a programmable copy from PLC itself by doing uploading and downloading as per your requirement. Now, by using PLC, it is possible to provide both online and offline modification to your system or machine or panel as per the customer requirement, as it is small in size and you can provide both manual and auto control. This picture shows the PLC of make Allen Bradley as well as Mitsubishi and others. Now, the main question comes how you can program PLC. So, in simple sense, if you want to program PLC, you need to have few idea about such a thing. First, what kind of PLC are using, what make PLC are using, and according to that PLC, you might have to use its own software interface. Then and then only you can provide the logic to develop or to implement in your application. And to install that software, you need to have a compatible system, computer, laptop, or an handheld terminal. By using that, you can provide that required logic or design that required logic as per the requirement. But to deliver that kind of logic, you have to develop a communication between your control hardware, between that software and that particular hardware. And to deliver that kind of communication, you require a programmable cable that will form that physical connections. Process chart and sequential flow charts are required. According to that, you might understand what are the procedure and delivering of that systems. You also need the details of input output devices and the required processing. According to that, you will functions and implement the programming. And of course, you need PLC to do such a purpose. The same thing is represented over here using showing the pictures of that devices. The main components required to perform an automation. The main thing is you need process instruments, which is also known as sensors, and you have to provide that signal to your controller or control hardware. That signal is again given to your final control element, and to function that you have to provide programming and monitoring system to your controller so that you can provide logic as well as monitor that logic according to that it is functioning and which is installed in the panel. Here it shows the pictorial representations of the previous file, that in which you collect signals from your sensors and process instruments and provide to that your control hardware, and according to which you are going to control your final control element using drives or any such starters that has to be installed in panel, which has its own monitoring systems like HMI or a SCADA system. Now, when you're transmitting devices, field devices scans any kind of signals that provide that signal to your control panel, and according to that signal, it is given to your SCADA software where you can provide the monitoring system. Here it shows the process of collecting information from field to your SCADA system where you can provide centralized monitoring. Now, here it is explained what are the process instruments and sensors. Now, sensors and process instruments vary as per the physical parameters. Here, parameters are described as the things which you are going to measure, like temperature, flow, and level, pH, humidity, conductivity, speeds. Any parameter which can be measured and that devices which measured such a thing is known as process instruments and sensors. Sensors with transmitter are the field devices placed in field who actually sense the parameter and send that analog signal to your control hardware. Sensors, you can say it's an eyes and ears for your particular systems to collect information from the real-time application and provide that signal to your control hardware. According to that, it functions and provide you the control hardware. It generally consists of both digital and analog signals. Here it explains about analog signals like RTD, which provides output in ohm form, as well as thermocouple, which provides in millivoltage and milliampere. And according to that, you provide that to your control hardware, and its outcome is generated to control your process. These are the picture form representation of the same above topic. Here it explains the different manufacturers and developers of such sensors and conditions used in industries. Leading manufacturers like Honeywell, Yokogawa, Emerson, Vare, Ederson Hauser, ABB, Order, and Pepperfush. Three type of control hardware can be used in control, either you can say closed loop or whole process. One is called PID controller, another one is your PLC, third is DCS, and others are using AC drives or any kind of drives. By using that, you can control your systems. PID controllers, you can say PID are generally a mathematical controller which provide or which predict the condition by which you can form or you can generate your final outcome. In PID, it consists of three kind of controller: P, I, and D itself. The process of P is that to control the or find the radiation in what proportion your signal is collecting information, and in I it provides the sampling duration of each signal provided in the previous condition, and in D it predicts the what kind of additional or elimination is required to sustain the required set value. That is the basic fundamental of PID controller. Now, programmable controller interface between your field input element like switches, sensors, push button with your control hardware or actuator. It consists of input module, CPU, output module, and internal connection using bus system, and it requires power supply to function. The configuration of PLC is being shown over here. Function of automatic controller: how your automation or how your function is implementing the logic. You can say this describes the everything how any kind of controllers is functioning. Generally, controller functions or collect data or information from field and provide that data, which is known as measured value, to your controller, which in which you provide your reference or set value, which is pre-programmed, and according to that set value it compares that with measured value and provide you the control outcome, and that controlled outcome signal is given to your output devices so that you can achieve your automatic control. Next is PLC and SCADA control. Generally, you can say automation can be achieved using PLC itself, but PLCs and hardware devices which can provide only logic according to which your controller process can be implemented. But when you are implementing such a functions, you have to provide a monitoring system which can monitor such a process. By using only PLC, you are providing kind of a blind control in which you are just predicting that if I have programmed properly, I can achieve my output without any kind of hurdle. But there is no kind of surety that your outcome is achieved or not. There is no kind of monitoring that can provide the real time functioning of that process. To resolve that condition, SCADA system was introduced, and it is directly functioning in synchronization with your PLC so that it can collect real time data from your field and provide that to your SCADA, and you can monitor it in real time. Now, what is SCADA? SCADA is a software which works in synchronization with your control hardware, say PLC, for supervising and control with data acquisition. SCADA software which required PLC or computer to run itself. It can't be run independently without such a systems, and it requires a direct synchronization with your control hardware. It won't be able to function independently without that. Now, what kind of programming languages or levels of languages generally hardware or software use? You can say generally the programming languages or software languages are generally divided in three conditions. One is known as higher level or software languages. Another one is an intermediate languages, or you can say compiler level languages. And third is the machine level languages. The you can say, for example, operating system, the Windows or the iOS, are the programming codes behind that algorithm is an higher level languages or categorized in a software level language. Intermediate language or compiler level languages can state that any kind of coding that you provide for raw making, such as C, C++, they such comes in that kind of coding or compiler level languages. Whereas when binary numeric systems are provided, that kind of language is known as machine level languages. Features of SCADA software. SCADA generally provide dynamic process animations graphics. According to that, you can provide real-time process monitoring. That means it forms an mimic version of your plant, and by monitoring or by using that, you can provide real-time monitoring. In SCADA, you can link embedded any kind of control device to your system by which your monitoring system can be done properly. It is also used to provide real time or historical time trend or to your signal with direct comparison with time, by which you can also provide a sequential process chart or sequential statistical chart of your process. You can provide a visual based animated stamp with its alarm system. You can provide multi-layer security and monitoring system. By using that, you can provide real-time security layer in which no one can access without the authority of that system. You can provide conditional unconditional event. Even you can also maintain recipe by monitoring SCADA, and you can exchange data between softwares by using DDE, and you can also create an open biz connectivity with various controllers and monitoring systems in any remote area using SCADA. Now I will provide you the and video representation of automation and where it is applied and application related to automations in the video. I hope so now that you understand the advantages of automations and application related to automations and where it is applied and how it is functioning. This video represents and shows the each and every part where automations can be applied and used
Was
in
very
real time.
informative. Your session was very informative and very good presentation, sir. Whatever you said with us, which is very valuable knowledge. And thank you so much, sir, for your support and give your time to us for 1 hour. Thank you so much, sir.
It was my
And
pleasure. And if there is any kind of requirement related to this, you can approach us. Your representative, ma'am, has our details, and you can contact her. According to that, you can find the communication medium to contact us, or you can contact us on NCVT Private Limited. We are available in both social media as well as in nearby locations. You can visit our office. If any kind of requirement are related or if you want to learn more, you can contact us directly. We are also available in social medias. You can check out our websites as well as our social media page. It would be very appreciated. I hope so
oh,
this presentation was helpful and enlightening for you.
yes, sir, it is very informative. And thank you so much, sir. We will give you a appreciation certificate to you. Ma'am will be sent to you.
Thank you, ma'am. Have a
Okay,
good
sir.
day.
Have a good day. Thank you. Thank you so much, sir.
Bye.
Bye.
Thank you.
Thank you, sir. Wait a minute.